Hello friends, here in this video we will see the pressure variation for a fluid at rest. I'll start this topic. Pressure variation in a fluid at rest. To understand this pressure variation in a fluid at rest, here I'll draw a simple diagram that we have a huge mass of fluid here. This fluid can be anything. Here suppose I assume it is to be water. Now, if we have an element which is kept inside this water and if we have the height of the element and here this would be the width of the element. Now, see, pressure variation in a fluid at rest, it can be explained by hydrostatic law. So this hydrostatic law, it states that the increase of pressure at a point in a static fluid is directly proportional to the weight density of the fluid. So here I have written the statement of hydrostatic law, and the statement is the increase of pressure at a point in a static fluid is directly proportional to the weight density of the fluid. It means if we want to find out how much is the pressure acting on this body along the depth, it means here if we go deep into this water, when we reach this element at this suppose height from the free surface, this is the free surface of water. So at this top end of the body, here we would be having a value of pressure. Similarly, if we go on increasing the height from the free surface, that is if we are going deep into this water, then the pressure intensity is directly proportional to the weight density of the fluid, and therefore I'll write down intensity of pressure. It would be given by, hence intensity of pressure is given by, here I'll write down the formula onto the next page, that intensity is P is equal to weight density multiplied by height. This relation is very important, where P is the intensity of pressure at a particular depth in a fluid. Its unit would be Pascal, that is Newton per meter square. W is the specific weight or weight density of fluid. Its unit would be Newton per meter cube, or it can even be kilonewton per meter cube. H is the height from free surface of liquid to the point up to which pressure is to be found out. So now here I have written the relation, that it means if we want to find out pressure at any given height for this body, that pressure can be found out by using the formula W into H, where W is the specific weight or weight density of the fluid, because as per hydrostatic law, the pressure intensity is directly proportional to the weight density of the fluid. Into H, see, H is the depth. H will go on changing. It means here pressure is also directly proportional to H, because if H is maximum, that is from the free surface of liquid to up to the bottom, there the height would be maximum. Like for the example here, so here we see pressure intensity, it is equal to specific weight into the height up to which we want to calculate the pressure. Now this H will go on changing, and if I want to show it on the diagram, then H will be maximum at this location. That is from the free surface of liquid to the bottom of this body, we would be having the maximum height, and at this maximum height the pressure intensity will also be maximum, because as we know, pressure intensity is directly proportional to the height. So if we see the pressure which is acting at the top of the body, here the pressure intensity will be less, and the moment we go on increasing this height and we reach up to H value, at this location the pressure will be maximum. So here we have seen that pressure is directly proportional to the height, and as I have written the formula previously also, that therefore intensity of pressure, it can also be written in this form, that specific weight or weight density, we know that it is equal to rho into G. So the formula becomes rho GH. So even if we know the density, this density is the mass density, and we know the acceleration due to gravity, H is the variable. We go on changing the value of H, we would be having different values of pressure. So here in this video we have seen pressure variation in a fluid at rest, and we have understood that with the help of a diagram and hydrostatic law. I hope this concept is clear.